Good morning, everybody. Welcome back to one new episode of MakerBot Chats. My name is Felipe. As always, I'm your host here, leading you guys through these quick, casual conversations on our printers, 3D printing in general, best practices, how to do stuff with the printers, how to get the most out of the printers. And happily so, we're now starting, well, this is our 10th episode, right? As you guys may have known, last week, the 2 weeks back, we had a couple of summits, both for professionals and for EDU, hosted by MakerBot. We invited a bunch of different people over, basically to talk about 3D printers. We had student astronauts, we had NASCAR races, we had like actual students from different high schools coming in and talking about how they have used MakerBot printers themselves, what's their experience, what do they do with them, and some of their tips. It was pretty good. I would highly recommend, if you guys haven't or didn't watch them, to go over to our website, and then in the resources section you can find all of the the streams, basically not the live streams, but the conversations that we streamed last week. One of the guys was actually like one of the designers, the costume designers for Black Panther, the movie. He's worked with Stratasys, and Stratasys being the MakerBot partner company. He talked about a lot of crazy applications, but I won't spoil it for you guys. You should definitely go watch it if you haven't. But without further ado, I'll get started with today's episode, which is a little bit of a follow-up of last, 2 weeks ago, which was just a sketch overview, right? A couple of weeks ago, we talked about the MakerBot Sketch. How big is it? How do you use it? What are the properties? What are the main differences or the key differences between the Sketch and the Method, which are kind of like our flagship printers right now. Method for professionals, Sketch more geared for EDU. However, having the Sketch right here with me, I wouldn't dismiss it entirely as like a, say, basic printer. It's actually rather capable, right? Really useful, a lot of fun to use, straightforward, and ultimately it gets the job done in a different way than Method. I would say that Sketch is perfect for quick prototypes, like to test different ideas out, and Method is more geared towards material differences, right? You really want to be choosing, say, if you're using ABS or now carbon fiber, which we just introduced a couple of weeks back. But with Sketch, you have two material options. You have PLA and you have the tough material, and that's pretty much more than enough for what you will be able to do with this printer, right? So last week, we talked a little bit on the build volume, right, the size of it. I've heard a lot about people wondering like, okay, how big can I print with a printer? It feels a little bit too small, or maybe it comes across as way smaller than what Method is. And to be honest, so this is a cube, 14 by 14 by 14 centimeter cube. That's about, what is it? Close to 6 inches cube, right? It's about the maximum build volume of the Sketch. It's pretty reasonable, right? And then the point of today's episodes is to talk about what happens when you try to go beyond that build volume, and what can you actually do beyond just printing like a large cube in the printer, right? And today's example is a really exciting one for me because I've been playing with it quite a bit. I actually designed this first, this claw, for the Replicator Plus a couple of months ago, and it's a very simple assembly, right? It's sorry about the sound. And by the way, we have a new camera, which is amazing. Hopefully, you'll be getting way better details of the parts. I'm really excited about it. Hopefully, it will work. It will work, because last time, for some reason, it was like flickering around. But in any ways, assemblies and Sketch. So I'm going to be talking about this specific assembly, which is, you can see it's sort of a robotic claw meant to be used like it's basically a linear actuator. I'll stop talking for a second because as I move it around, the sound is just too loud. But I'll show you how it moves first. Just making sure that you guys got that. But you can see, like, it's a straightforward element. Linear actuator pushes these elements out like so, and that makes the claw open. And as the linear actuator retracts, it brings the claw or the fingers back in, and closes on whatever it is that you're trying to pull up. So let's say something like, there we go. Just like trying to get an object and putting it back down. This is just like the first pass at it. I wish that I had the time to develop the electronics behind it, like just putting some Raspberry Pi and the actual actuator to make it move like with a controller or something. But for now, just talking about the specific assembly and what it took for me to make this, right? Starting by the fact that, as you can see, this claw is way bigger than the actual build volume of the sketch, right? It goes beyond the build volume. And the reason why I'm able to do that is because this claw is, as you can see with the colors and the highlights and whatnot, the claw is split into multiple segments. And I'm going to talk about the different segments in a second. So I'll bring just real quick, here we go, the different parts. So let's talk first about the different parts that make up this concept, right? First we have the fingers right here. So these blue tips, I call them fingers because they are quite literally the element that will grasp and hold to what you're trying to catch. In this case, just this dodecahedron, right? Then the second element are these green beams, which I called the phalanges, right? Basically, I'm just naming them after my hand. So you have the fingers, you have the phalanges, which are these three elements. As FYI, industrial designer, you get to take anatomy classes back in college, but anyways. So the phalanges, which are the element that will join the finger towards the center core, or the core element here. So here you can see how these phalanges come, all three of them come and nest right in the center element, this little bolt here that is going to be receiving them. Third element, sorry, actually 1, 2, 3. Fourth element is going to be this the actuator, right? So joint that I'm pushing up and down to actually make the part move. And the final element, well, second to final, I guess, but the final element is going to be this, what I call the trident, right? The trident, which is the main component of the assembly. It's going to be what ends up hosting the whole thing. And then, of course, I also printed the actual bolts of the assembly. So these orange parts, or orange bits, are just printed bolts. The way that I did that, let me disassemble this for a second so I can push them out. Here we go. So I printed, let's see if the camera, yeah, it's picking it up. It's actually doing a great job at keeping the focus tight. So the bolt itself is both the bolt and the nut. Both are 3D printed. And you can see like the tolerances are enough for me to actually play with how much give do I want to have in the assembly. In this case, if I want like a smooth fit, the offset right here is but it's actually 200 microns between the different circles. So the circles here in both the finger and the phalange are about 3 millimeters. This guy, the bolt itself, has an offset of 200 microns, so 0.2 millimeters. And then the nut itself, which is going to wrap and enclose this thing. Let's see if I can get it right in the camera. Here we go. Yep. There we go. Right. So the nut itself, which is going to actually keep everything tight, and I have, I think 1, 2, 3, yeah, so 9 of them. It's the thing that puts everything together and completes the assembly. So all of the whole assembly is 3D printed, right? In different parts, different components, different colors. You can get a little bit more creative when you're printing an assembly because you're not simply locked down by the one material or the one color, right? Some assemblies actually do benefit from that material mix. So let's say if I had a part that needed to be a little bit stronger, or that we'll be seeing a little bit more wear and tear, I could print it with our tough filament, which by the way is now certified by Green Guard to be office, classroom, and now, well, here in my living room, right, house safe. That's just a great thing to keep in mind and to give you some more peace of mind of how safe these printers are nowadays, especially like for somebody who's thinking about summer activities for the kids, as they are now not at school but like having some time at home. Just something that's great to keep around and to have around the kids. But so those are the main elements of the assembly. Now, how do you print this assembly, right? The actual elements. I am going to show you first my tubular plates right here, right? So those are the tubular plates that make up my assembly. As you can see in my final model, the one that I'm holding, this has more than tubular plates. The reason for that was that this element was my first pass at printing it, right? I was sort of iterating as I went. So I printed only some of the components together. In this case, I printed the trident and I printed the core hub together. Then I printed the phalanges on a second set, and then I printed the fingers on a third set. And the final element that I printed was the main hub. However, once I was happy with the assembly, once I knew, that the tolerances were right, that the assembly was actually working the way that I expected to do it, I was able to simplify the printing process a little bit and have it, fit in 2 build plates. The great thing about the MakerBot Sketch is that it actually comes with 3 build plates. I mean, not saying that you have to actually keep the parts in the build plate until you're ready to make or to put everything together, but it's definitely helpful to be able to just swap the build plate and print the second one. So I'll take this guy out. I printed the blue one actually overnight, last night, right? But these are all of the components, so you see them both, well, in the photo, and I'm just holding them here, just like doubling down on the way to print the assembly, right? So in the build plate number 1, I am printing the phalanges, and I'm printing the fingers. I am printing also the screws and the bolts. And on the build plate number 2, I am printing the hub, the core, and the trident, right? And you can see how all of the parts are like, as long as you can nest them together, you're completely fine to fill up as much as you want of the build plate. And that's kind of the idea, right? With something that's so robust, so trustworthy like the sketch itself, it's great to have that peace of mind of saying like, hey, you know what, I just need to print, whether that's a single assembly with multiple parts, or I want to print many parts at once. And also, ultimately it comes down to being able to expand a little bit what might come across as the sort of the basic components of the printer, meaning the minimum or maximum build volume, and how do you go beyond that, right? How do you again expand that build volume and ultimately expand the capabilities of the printer, right? So as you can see right here, the build plate is super easy to remove. Here on Sketch, it has a different system than with Method. So with Method, you have magnets that attach the build plate to the build surface. In Sketch, you actually have a spring-loaded build plate, right? So you can, I don't know, let's see. Oh, let me go back to the video just a second. Here we go. All right. Sorry. So here you can see like the build plate. I'll just take it back out because I just realized that you guys weren't seeing that. But the build plate itself, it's made out of this polymer and has the grip surface with all of the labels in it, and a little clip here that helps keeping it in place. The way to attach it is just pushing it down, pushing this element down, right? This is actually the heated build plate element. So this will get hot. This gets, I believe, if I'm not mistaken, it's 100 degrees C, or a little bit more than that. Unlike the Method, as we said before, this is not a heated chamber printer, it's just a heated build plate. So it's only going to heat the first couple of layers here. But that's great just to make sure that the parts are correctly adhered to the build plate, and ultimately to get successful prints, right? So to put that build plate back in, pushing it down, sliding it in, and that's it. It's as easy as that, right? Right now, both my build plates are done, so I'm not starting a new print, but you can see how easy it is to just swap them in and out. And instead of waiting, let's say that I wanted to post-process the parts, or I wanted to get started, I'm going to take some time before I remove the parts from the build plate. The good thing about the Sketch is that it comes with 3 build plates per printer, so you know that how it comes with 2 printers in a single kit. It also, each printer has 3 build plates, right? So you can use them either just as replacements, or you can use them to expedite the process of swapping build plates in and out. Especially like if you think about having a larger project, or if you think about having multiple students submit projects at once, it's great to just have that ability to swap in and out the build plates. Now, talking about a little bit, let me fade back here, on how to create those assemblies, right? So that's another thing that we get asked a lot, and I'm going to show my original Rhino files. So I need to check one thing though, because I am not sure. Let's see if it's actually working. Yeah, so I'll have to apologize because for some reason the window is not refreshing on my assembly, but you can see how basically what I did in Rhino there. So this is my Rhino file, right? This is my layout. And you can see how I have those little curves defining what my build plate area is going to be like. So since I already knew that I wanted to put as many parts on the build plate as possible, what I did once I had all of the different components was I just drew in Rhino, and this is, I'm using Rhino, but you guys might be using Fusion 360 or Tinkercad, or I don't know which other open source software you might be using, but anyways, it doesn't really matter. The point here is that you can just define that area, in this case Sketch's maximum build volume, which is going to be 149 millimeters square, right? You just draw that square, and in that square you start placing your elements in, right? So what I did right there, and you can see like those two squares on, you know, both the lower left corner and the lower right corner, you see those two squares that host or that have all of the little pieces assembled there. So I just take all of my parts, right? I assemble them, well, I distribute them on the build, on the sort of, how to call it, the phantom build plate or the pre-build plate. And then once I've done that, I just export all of the parts as a single file, as a single STL, right? So I'm going to go ahead and select all of the parts. And again, I'm sorry, I'm not sure why it's not, I believe it's just my computer is running out of space. I should probably clean up my hard drive more often. But I just select all of the elements on that build plate and then export them as a single STL. That's really important, and I'll show you why in a second. So once I've exported them, and I'm going to move you guys now to MakerBot print, right? Once I export them, I can just take that single STL, and in this case, I've got already one of the build plates preloaded, but you can see how if I add a new build plate in MakerBot print, add a model, select claw build plate number 2, right? And it's just going to import all of them as a single element. Now, you can either do that, or if you were to pick like individual elements from your assembly, you can also do it in MakerBot print. Let me just show you what I mean. So, for example, I can bring in the trident, the core element here, right? And I'm going to orient it, place a face on the build plate. In this case, that bottom this tool I like a lot, right? It allows you to select one of the faces of your part and define it as the bottom, the top, or whatever it is. So in saying here, I'm just putting it as button, and the part is right there. I'm bringing another part. Let's say I want to bring the finger here. Just a second, finger. It inserted it in a second different build plate. I can just move it to build plate number 3. There we go. The parts are intersecting right now, so I can just move them around right here. You can see how, so this box is actually red because I am out of bounds with the fingers of with this finger of the maximum available build volume for Sketch, right? And that's just because of the way that the software places the finger in it. So I have two options. I can either scale that part, or since I know that the actual largest dimension on that square is going to be that diagonal between the two corners, I can simply orient that part, select that finger, say 45 degrees. It's going to rotate it a little bit.